The last lesson in Topic 9 is Lesson 9.6, Electrolytic Cells. So, we just talked about voltaic cells and spontaneous redox reactions. Well, what happens when you want a redox reaction to occur that is not spontaneous? Well, to do this, you can use an electrolytic cell. And an electrolytic cell uses an external source of voltage, like a battery, to cause a redox reaction that would otherwise be non-spontaneous. So here's a short video on electrolytic cells. Please make sure that you watch the entire thing.
The Earth's crust contains many compounds. But the compounds themselves aren't as useful to us as the elements they're made up of. This rock contains aluminium oxide. Split the aluminium from the oxygen and you have one of the world's most useful metals. You can split a compound using electricity. The idea is to pass an electric current through it, a process known as electrolysis. A circuit is set up using 2 carbon electrodes, an ammeter and a power supply. The white powder is lead bromide. Switch on the power supply and nothing happens. The ammeter reads 0. Solid lead bromide doesn't conduct electricity. It needs to be molten. Lead bromide melts at 370 degrees Celsius. Switch on now and a current flows. In this circuit, the electrode on the right is positive. The one on the left is negative. As electricity passes through the molten lead bromide, chemical reactions start. On the left, at the negative electrode, nothing appears to be happening. But at the positive, bubbles mean a gas is being produced. Placing small tubes around the electrodes traps any gas, making it easier to see their colour. What could the brown gas be? The gas is bromine. Although nothing obvious appears to be happening at the left-hand electrode, pouring the molten lead bromide away reveals a small silvery metallic bead. This is pure lead. So, passing an electric current through molten lead bromide breaks it down into the elements lead and bromine. To work out why this happens, imagine you can see the charged particles, the ions, in the compound. There are positive lead ions and negative bromide ions. Once the power supply is switched on, the lead ions are attracted to the negative electrode. The bromide ions are attracted to the positive electrode. Lead ions pick up electrons. They lose their positive charge and form lead atoms. Bromide ions give up electrons. They lose their negative charge and become bromine atoms. These form a gas. Electrolysis of lead bromide only works when the compound is molten. Why doesn't it work when the compound is solid? Change the compound from lead bromide to zinc chloride and the products of electrolysis will be different. What would you expect to see happening when electricity is passed through molten zinc chloride? This time bubbles of a very pale gas appear at the positive electrode. It turns damp blue litmus paper red and bleaches it lighter. So what gas is it likely to be? Again, nothing appears to be happening at the negative electrode on the left. But pouring off the molten zinc chloride reveals a bead of pure zinc. In industry, electrolysis is carried out on a huge scale. Massive amounts of electricity are used to extract reactive metals, like aluminium, from their ore.
So again, remember, electrolytic cells use an external source of voltage. The electrolyte is the reactant in electrolysis, and it is usually a liquid. The electrodes is where the redox reaction occurs. The electrodes remove the charges on the ions and form products that are neutral elements in electrolysis. So in this, the ions are discharged. And electrolysis is used to separate many non-reactive metals from their ores, so lower cell potential values. So here's an electrolytic cell, and the first main component is this battery up here. And the second thing is, you'll notice, is that it all occurs in the same container. So it's very important that the electrodes do not touch. If they do touch, you complete the circuit and you can have sparks. Now, in an electrolytic cell, the electrons are pushed towards the negative electrode. So they're pushed towards the negative electrode where reduction occurs at the cathode. And electrons are released at the positive electrode, which is the anode where oxidation occurs. Now, these positive and negative electrodes are reversed from the voltaic cell. The ions are transferred through the solution, and this is where the electrons are also transferred to the ions at these electrodes. So positive ions are attracted to the negative electrode, and negative ions are attracted to the positive electrode. So here's the difference between a voltaic cell and an electrolytic cell. In a voltaic cell, oxidation occurs at the anode and reduction occurs at the cathode. Remember, red cat and ox. Okay? But in a voltaic cell, the anode is negative and the cathode is positive, because you want the electrons to go towards the positive electrode for reduction in a voltaic cell. In an electrolytic cell, again, oxidation still occurs at the anode and reduction still occurs at the cathode. But here the reduction has a negative electrode, so the cathode is the negative electrode because this is what's giving up the electrons for reduction, and the anode is positive because that's what's taking the electrons for oxidation. So to determine the products for electrolysis, the first thing you're going to do is identify all the ions present in the electrolyte and determine which will migrate towards which electrode. When there's more than one ion at an electrode, you have to determine which will be discharged. So you'll write the half equations at each electrode. Then you'll balance the electrons lost and gained at each electrode, and consider what charges would be observed in the cell as a result of the redox process. So the electrolysis of molten salts means you melt the salt. So for example, in the movie, the lead bromide was melted. So there's no solvent. You only have one positive charge and one negative charge. However, the problem with this process is that it needs very high temperatures, which costs a lot of money. So here's an example of a molten electrolysis. Describe the reactions that occur at the two electrodes during the electrolysis of molten lead bromide. Write an equation for the overall reaction and comment on any likely changes that would be observed. So here we have lead bromide and we're melting it, so we're forming the ions in solution. And if we have electrolysis, we have a negative electrode and a positive electrode. So the lead will be attracted to the negative electrode and this is where reduction will occur at the cathode, and the negative ions will be attracted to the positive anode, where they will be reduced or gain electron, or sorry, where they will be oxidized or lose electrons. And so at the anode, the bromine will lose electrons to become bromine gas. So scratch this out. They're losing electrons, so they're becoming bromine. And the lead will be gaining electrons at the cathode, so it will be reduced. And so overall, our reaction will be lead ions plus bromine ions will go to lead plus bromine gas. And so any changes that will be observed we will see some bromine, which is brown, and the lead will be a gray metal. So sometimes when you're trying to do molten electrolysis while saving some money, you'll add some other compounds to lower the melting point, because this will help break up some of those intermolecular forces. That will make your electrolysis more economical. So for example, sometimes salt is added in order to help break up those intermolecular forces. Another thing that is oftentimes added is calcium chloride. And if you add calcium chloride, the sodium will be reduced in preference to the calcium. Another type of electrolysis involves ionic compounds that are dissolved in water. And in this case, because you have an ionic compound and you have water, more than one ion will accumulate at the anode and the cathode. And so you need to decide which one is going to be discharged. So this is called the selective discharge, where you consider the factors that determine which ion will be discharged at each electrode. So water can be electrolyzed, and the ionization of water is low. So to add ions will increase its conductivity. For example, if you want to electrolyze water, one thing that you can add is sodium hydroxide.